So both of these equations have an argument that you can simplify. So what I mean by that is it is possible to simplify this. This is an actual number. If you're given the base and the answer, then you should be able to tell me what that number would be. Because what this is saying is 4 to the what power is 1 over 64. Now, because it's a fraction, we know that our exponent is negative. So anyone know what would be my exponent? -3. So now we're going to set that equal to 0 and factor it. All right, so we have x squared minus 4x plus 3. Let's go ahead and factor it down. We need two numbers that multiply to be a +3. Two numbers that multiply to +3 and add to -4. So two numbers that multiply to +3 and add to -4. What'd you say, hey? Yep, -3 and -1. Go ahead and set both of those equal to 0. My first answer would be +3. And my second answer is +1. All right, number 4, we're going to start off by evaluating that log. We need to figure out what is the exponent. 2 to the what power is 1 over 32. Negative, did you say -8? -5, yep, -5. So the answer would be -5. Again, it's a quadratic, set it equal to 0. Now this time though, we cannot do a shortcut because A is not 1. So go ahead and make your box. So we got our A here. We have our C here. So A times C would be 2 times 5, 10. B is 7. So we need two numbers that multiply to 10 and add to 7. That's what's going to go inside of my box. Two numbers, they multiply to be 10, and they add to give you 7. 2x and 5x, or 2 and 5. So let's go ahead and put our 2x and our 5x in. And then let's take out our GCFs. So the top row, I'm taking out a 2x. The bottom row is a +5. Let's go ahead and set that equal to 0. And when we solve that, we get a fraction. So subtract the 5, divide by 2. All right, now we need to look at our box again. This time we're going to look at the GCFs of each column. So for this first column, I could take out an x. The second column, only a 1. So x plus 1 equals 0. X equals -1. So there's a couple questions on your butterfly where you have to evaluate it, and then you just solve it like a regular equation. All right, any questions about the first two? I guess I could go through and renumber these the right way. I mean, I don't know if that matters, but I can do that. So this is our number 1, and this is our number 2. All right, so now let's talk about log equations. And you don't have to write the graph down or what's at the top, but what I want you to know is that unlike an exponential, You cannot, so you could take any number and raise it to any exponent. But you can't take the log of any number. So with your calculator, I just want you to do a test. I want you to type in log of -1. Log of -1. We got one right there. Calculator there. Any other calculators? Anybody see any other? And there's another one in this row. Any other ones? Okay. So when you type in log of -1, what happens? What does it say? Domain error. So what does that mean? You cannot take the log of a negative number. So that means that we have to be careful what answers we select. Just because we get an answer, that doesn't mean we can actually keep that answer. So the way we check it is by substituting our answer into the argument, which is what we see in these parentheses. All right, so now, because when you look at both of these graphs, it doesn't matter what your base is, it will never be negative. You will not have a graph over on the left side of the y-axis. That's impossible, no matter what. All right, so now let's go ahead and copy down question 3. And we're going to solve this similar to how we would solve an exponential equation. We know that if the bases are the same, we got 2 exponents on both sides with the same base, we can drop the base. That's the same thing with the log. If you have a log with the same base on both sides, they cancel out. So what we're left with is just, excuse me, x plus 4 equals x squared minus 2. So we can set our arguments equal to each other because they're both a base 3. So they cancel out. Now, when you factor this first number, this x squared has to be positive. So that's why I'm going to move the x plus 4 over. Now, I do have a student who does quadratic formula for everything. So if you're one of those people, it doesn't matter. You can have a negative a value. But if you're choosing to factor, the a value has to be positive. So now I have x equals x squared minus 6. And then when I subtract the x, I don't have a like term over here. So it's just going to go in the middle. So 0 equals x squared minus x minus 6. All right, go ahead and factor that down. We can do a shortcut. We need our 2 numbers. They multiply to be -1, and they add to be -6. What'd you say? 2 and 3? Which one would be negative, the 2 or the 3? The 2 is negative. When I add those, -2 and 3, do I get a -1? No. So we got to flip those signs and make the 2 positive and the 3 negative. So go ahead and solve both of those. And you should get x equals -2 and x equals a positive 3. So when I say check, what I'm trying to say is I need to make sure when I put the -2 in that x plus 4, is it positive? I don't care what it is. It just has to be positive. So if you take -2 and you put it here, is that going to be positive or negative? All right, what about if I put it over here? Positive. So that means because both arguments stay positive, that means x equals -2 is an actual answer. That's an answer. All right, what about 3? If I put a 3, is that going to be positive or is it going to become negative? 3 plus 4 would be positive. What about 3 squared minus 2? All right, so this actually has 2 solutions. Now later on, we will come to some that won't work. So we only have to do that check when it's a log equation. Okay, let's do number 4. So we cannot drop the log because we don't have it on both sides. So what do you think we're going to do with this one? No, never do that. That's horrible. We're going to rewrite it. So we're going to change it because remember, a log would be log base answer equals E. And we're going to write it in exponential form, which would be b to the e equals a. So the base is what? What's the base? What's the little bitty number next to log? 4. Now you go across the equal sign to get the exponent. So that would be a 4 squared equals x squared minus 6. X. So that would be 16 equals x squared minus 6x. All right, more factoring. Go ahead and factor this down. Find your two numbers that multiply to be negative 16 and add to a negative 6. So your number should be negative 8 and positive 2. So that means I have positive 8 and negative 2 as my answers. But again, we need to make sure that we can use them. So I want you to just check it in the argument. So we need to make sure that 8 squared minus 6 times 8 is positive. So if you need to check that in your calculator, you can do that. Well, we need to make sure that 8 squared minus 6 times 8 is positive. So it is positive. It doesn't matter what it is. I don't care what the number is. It just has to be positive. So because that's positive, I can keep the 8. That is one of my answers. Now let's do the same thing with negative 2. Negative 2 squared would be 4. And then negative 6 times negative 2 is 12. So that would be 16. So this is also positive. Please remember, if you're using your calculator, you have to put that in parentheses. All right. Let's keep on moving. Now we're at number 5. Go ahead and copy this one down. Right? This is number 5, right? Was that the last one was 4? Yeah, okay. All right, so number 5. So do you think this is an exponential equation or a log equation? Exponential. We don't see a log or ln, so this is exponential. Whenever you're solving an exponential equation, you have to isolate the base. This right here has to be by itself. So before I can do anything, I need to get rid of the 6. And it's positive. So am I adding the 6, subtracting the 6, multiplying by 6, or dividing by 6? All right, let's do that. So then that would be e to the power of 2x equals 5. And I'm going to give myself a little bit of space. Now, if you can't rewrite both sides with the same base, we need to use a log. So I can't rewrite 5 with a base e. So to get rid of e, I need to use a log. Which log has a base of e? Natural log. I want you to put a natural log in on both sides, because these are inverses. They cancel. So that goes away. That 2x, that's an exponent, it's in the sky, it's going to come down. Now that 2x is no longer an exponent. It's just 2x equals the natural log of 5. Divide both sides by 2. X equals the natural log of 5 divided by 2. That is my exact answer. That's the exact answer. Now let's type it in our calculator to get our estimate, or the approximate. So when you're typing it in, if you type it in ln and it starts in parentheses 5 divided by 2, that's not going to work, because this means you're taking the natural log of 2.5. If you're not using the fraction bar, you have to type in natural log, close the parentheses after the 5, and then divide by 2. That's how you correctly enter it into your calculator. Okay, Jasmine, what you get? 0.805. All right, anybody else get 0.805 for their answer? If you didn't raise your hand, I can help you type it in. So there's 2 answers, the exact answer and the estimate. And I don't know, on the test, it might ask you for both. Okay, let's look at 6. We kind of did one. Let me go back real quick, because we did one like this here. This is the exact same thing, except it's a ln. Okay, so natural log is a log. We have to do a rewrite. We have to rewrite it. And what's the base of a natural log? E. So I'm going to say e to the power of what? What's my exponent? E to the power of 4. So e to the 4th equals 5x plus 1. All right, now we're going to find the exact answer. So what do you think I'm going to move first over here? That 5x plus 1. What's going to go first, the 5 or the 1? The 1. How do I move the 1? Subtract it. So that would be e to the 4th minus 1 equals 5x. And now we need to get rid of the 5. The 5 is being multiplied, so we're going to divide it. So I'm going to divide both sides by 5. So this is my exact answer. Now this is a little tricky when you type this in the calculator. So you're going to have e to the power of 4 minus 1 divided by 5. Now it's really important that you know, on the calculator, you have this little button with the little arrows, this little circle thing. You have to use that to get out of the exponent. Because if you don't, you're changing this to e to the 3rd. So I would hit the fraction button first, because all the yellow calculators have it. To get e, you have to hit the green key and then ln, because ln and e are opposites. So if you want to pull the e up, hit the green key, which is ln, the e, and then, hit the green key and then ln, and you should get e. So e to the 4th, arrow out, minus 1 divided by 5. So this is my 3rd time doing this. This was the one where a lot of students had a hard time typing it in. So I'm going to Did you type it in? Yep. So 10.72. If you did not get 10.72, raise your hand. I'll come help you type it in. So I think that was you used the negative. So and it's so picky about that. Yeah. Anybody else need help typing it in? Okay. All right. I think we're just about done. Let's look at number 7. So I'm going to give you a few minutes. I want you to try to do this one by yourself. See if you can do this one by yourself. So you're going to isolate the E. Get that by itself first. Then you need to put in a natural log to cancel out the E. So take a few seconds, try to work it out, and then we'll do it together. Good. At least we all started by adding 5. That's hopeful. Okay, that's good. Seems like this is where we all kind of got stuck. We added 5 and then we stopped. Some people got to the next part and put in the LN though. But I do agree, we should all start by adding 5. So we cannot go any further. As long as x is an exponent, I can't do anything else. I need to figure out how to get rid of this E. How do you get rid of E? Natural log. You have to put an ln on both sides. When you put in the ln, that cancels out the E. That's what we want to do. So now that this is gone, this x plus 2 is not an exponent anymore. It comes down. So we have x plus 2 equals the natural log of 29. All right, we're not finished though. Now we got a minus 2. So we got rid of the E. Now we have to get rid of the positive 2. Sorry, how do we get rid of the positive 2? Subtract it. So here's your exact answer. X equals the natural log of 29 minus 2. Now, that's your exact answer. Now, when you type this in your calculator, It automatically starts the parentheses. If you put in 29 minus 2, why would that be wrong if I don't close that parentheses? That'd be natural log 27. You have to close the parentheses before you subtract 2. That's why the parentheses is there. So your exact answer, well, not the exact, but your estimate is what? What we get? 1.367. 67, guys. Nobody's excited about that? Wow. I expect Adrian to say something. You missed your opportunity. It's 67. 67. Okay. All right, that's number 7. Last one. Number 8. Now, this one involves a property. Okay, so before we can do anything, we are going to have to do a rewrite. But before we do that, we need to condense this down to 1 log. So what did we learn yesterday? If you're adding, what do we do with these? These are my 2 arguments. Do I multiply them or make them a fraction? Multiply them. So we have log little bitty 2. And then I have x times x minus 4. That equals 5. So let's go ahead and distribute that x. Take the x and multiply it by x minus 4. So that'll be x squared minus 4x. That equals 5. Now we can do a rewrite. So what's the base of my exponent? 2. What's my exponent? 5. So 2 to the 5th equals x squared minus 4x. Use your calculator if you need to. See what 2 to the power of 5 is. That's not 10. That's 2 times 2 times 2 times 2 times 2. So we got to figure out what that number is. And then we're going to subtract it and factor it down. So 32, so now we have to factor this down. 0 equals x squared minus 4x minus 32. So don't say it out loud, but find your 2 numbers that multiply to be negative 32, but add to give you a negative 4. So find 2 numbers that multiply to be negative 32. Add to be negative 4. What's my numbers? What'd you say, Kimberly? Negative 8, positive 4. When you set those equal to 0, I get 8, and I get -4. But we need to make sure we can use them both. So when I take 8, which is my first answer, if I take the 8 and I put it right here and here, are they going to be positive? Both of these, so we already know that's positive. What about 8 minus 4? Is that positive? So we can keep the 8. But when I put the -4 right here, I'm already out. You cannot take the log base to a -4. So there isn't an exponent that I can put on a 2 that will give me a -4. Even if I have a negative exponent, it's still, it's still positive. So this is out. We call that extraneous. So extraneous means we got a solution, but we can't use it. So Monday, we're going to continue working different types of equations. I mean, looking at this, though, I think the majority of these you can do. But number 12 is probably the hardest, but we'll do one like that later. Yes, I'm sorry.
We have to specify that that's extraneous.
If you cross it out, that's fine. But if you don't cross it out, then yeah, that means that you don't realize that that's not an answer. So at least put an X on it.